All right, and we have the 2024 Methods Exam 1, and today we're going to go through every questions of them. So, start with question 1. This is a easy diff questions. Immediately we know this is multiplication, so this is u times v. Diff of u times v would be equals to u dash v plus v dash u. And we consider e to the power of x, that is u, cos 3x is v, and our dy dx should be, so u dash is e to the power of x, v is cos 3x plus v dash. So in this one, all you need to know is, so when you diff cos of something, it has to be negative sign, but then you have the 3x, you have to times it by the diff of 3x. So the diff of 3x would be 3. So times by 3. So that will be negative sine 3x times 3, and then times by e to the power of x. So if we simplify this, it would be e to the power of x cos 3x minus 3 sine 3x. All right. Question B, fx equals to log base e x cubed minus 3x plus 2. Find f dash of 3. So you know that log e of fx would be f dash x divided by fx, with fx larger than 0. So we have f dash x would be, so diff of that would be 3x squared. Diff of this would be negative 3. Diff of a constant is 0. Then we divide by x cubed minus 3x plus 2, which is our fx. All right. So we want to simplify this. So maybe this is not simplified. Oh, we don't. We actually need. We only need to sub in number 3. So sub 3 for x would be 3 times 3 squared minus 3 over 3 cubed minus 3 times 3 plus 2. And that would equals to, so 3, that's 27 minus 3. The below is 27 minus 9 plus 2. 27 minus 3 is 24. And then the below is 27 minus 9 is 18. And then 20. So that 6 over, 6 over 5. Okay, so divide the denominator and the numerator by 4. Okay, that's your final answer. All right. Moving on to the next one. So we have the simultaneous equation. Determine the value of k for which the system equations has no real solutions. So when do we have no real solutions? Is when the two lines is not crossing each other at any point. So if it's not crossing, that means that it's parallel. And if it's parallel, then the gradient is equal to each other. Okay. So all we need is we want to find m1 for the first one and m2 for the second one, and you want to equate m1 and m2. Okay. So we wanted to put it into y equals mx plus c form. For the first one, 3kx minus y, 2y equals to k plus 4. So we want to bring the x to the right side and the y for the outside. So negative 2y equals to 3kx plus k plus 4. And then we divide both sides by negative 2. So y equals to negative 3k on 2 times x plus, maybe we can minus here. Okay, so k plus 4 divide 2, because we already have the minus here. All right, so our gradient m1 should be negative 3k on 2. For the second one, so k minus 4 times x plus ky equals to negative k. We're going to do exactly the same. So put the x on the other side. K minus 4x minus k. And you want to divide both sides by k, which means k minus 4 over k times x minus 1, because k divide k is 1, right? So we have our m2 would be k minus 4 on k, and we want to equate m2 and m1, okay? So no solutions when m1 equals to m2. So k minus 4 divided k equals to negative 3k on 2. So we have, so we want to times that by that, and then times this by this, and we equate each other. So k minus 4 times 2 equals to negative 3k squared, because k times k is k squared, right? And to solve for this, we're just solving the quadratic equation, right? So that'll be 2k minus 8 because we times it in, and then this is negative 3k squared. To solve this equation, we bring the 3k squared to the left side. So 3k squared plus 2k minus 8, that's equal to 0. And we want to obviously find the two numbers in the middle. That So maybe we can try. So 3k squared, maybe add 6k. If we add 6k, this is 2k, so we have to minus 4k minus 8. So we can see here this is 3k and 6k, and we can combine 4k and 8. Because you see how 3 times 2 is 6, 4 times 2 is 8. So it's just a technique where you find the numbers that add together to 2k, and we can, and also those number has to have the common factor that can be. So you know how I do it. So 3k, k plus 2 minus 4, k plus 2. So the k plus 2 here is a common factor. So that's why I choose 6 and negative 4. Okay. Oh, sorry. The explanation for, okay. So we want two numbers where it times by each other equals to negative 24, and then add by each other by 2. So a plus b equals to 2, a times b equals to negative 24. So if we think about this, the only two number that we can get is 6 and negative 4, because 6 plus negative 4 is 2. 6 times negative 4 is going to be negative 24. So we want to manipulate that fact, and we want to get this 2k to become 6k minus 4k. So we rewrite 3k squared plus, and that is negative 8 equals to 0. 3k is the common factor for these ones. So 3k, and then this will be k plus 2 in the middle, and then negative 4, also k plus 2, so times by k plus 2, equals to 0. Our common factor is k plus 2. The other brackets would be 3k minus 4, so equal to 0. When we solve for this, so k equals to negative 2 and k equals to 4 over 3, right? So we have two values of k. That is when it has no real solution. So basically two lines going parallel to each other, right? When it's parallel, it doesn't cross. It doesn't cross means that it doesn't have a solution. So that's pretty easy, right? All right. For this question 3, we see here this is a reciprocal function. So what about the reciprocal function that is important in this case? So we can see here this is a truncus, and so there's a power of 2 here. There's a negative 2 here, and what they ask is sketching and label the asymptotes, x-intercepts with the coordinates. All right. So let's first talk about the asymptotes. So the asymptotes is the value where x can't be equal to and y also can't be equal to that value. So whenever we find the asymptotes, we have to find the x asymptotes first. So you guys all know that a, so when you divide something, so a divided by b, and b can't be 0. So you can't divide anything by 0. So you look at this number. This is a fraction. Also, obviously, below the fraction, something below, can't be 0. So x plus 3 can't be 0, right? So if x plus 3 can't be 0, that means x can't be negative 3. So if x can't be negative 3, there is an asymptote. So the asymptote is the line where the graph will approach the line. So we go really close to the line, but never cross that line. All right. So when we draw the asymptote x, so our asymptote here is obviously going to be x equals to negative 3. So when we draw it, it has to be a cutted lines. So it'll be something like that. So we write x equal negative 3. And the way that we work out that's a vertical, but the way that we work out the horizontal one is we want to, so obviously the fraction can't be 0. So g of x can't be 0 minus 2, which means that it can't be negative 2. So there's an asymptote as at y equals negative 2. So y equals negative 2 here. And we want the equation of those, right? So those are the equations. So we know the truncus will look something like this. So we'll go like that, and that will go like that, right? But in methods, what they look for is the shape where it approach. So it approach the asymptotes. So it has to look something like that. And when you go like this, it has to approach. Okay, so make sure that you don't go like that. If you go something like this, that would deduct a mark because the shape is not shaping. So it's not a real shape of the chunkus. So yeah, a very critical point. It has to go really close to the asymptote. So which means that it has to approach the asymptote. Approach both of the asymptote actually. So yeah, something like that is enough. And next is we want to solve for the axial intercepts. So to find the x-intercept, we make y equal to 0. So we have 1 over x plus 3 squared minus 2 equals to 0. And so that means 1 over x plus 3 squared equals to 2. And then we continue solving that. X plus 3 squared equals to 1/2. X plus 3 obviously equals to 1 or plus or minus 1 over square root 2. Okay, so I don't have any more space, so let me rub this out. So we can continue writing x plus 3 equals 1 plus or minus 1 over square root 2. X equals to plus or minus 1 over square root 2 minus 3. Okay, so yeah, so the one that is here, which is the bigger one, that will be negative 3 plus 1 over square root 2, 0. And obviously the smaller one would be the one with the negative 1 over square root 2. So that will be negative 3 minus 1 over square root 2, 0. So those are your two x-intercepts. To find the y-intercept over here, you need to get your x equals to 0. So that is 1 over 9 minus 2. And that is negative 17 over 9 because negative 2 is actually negative 18 over 9 plus 1 over 9. That is negative 17 over 9. So we have this point 0, negative 17 over 9. So you just have that one. So just check one more time if everything is checked. So y-intercepts checked, x-intercepts checked. You have the axial asymptotes. You have the shape going right, and you should get 3 marks. Right? For question B, determine the area. So the area, you immediately think of integration, right? So the area bounded by x equals to negative 2. So we have to have a vertical line at x equals to negative 2. So it may be cutting the graph at that point. And we have the x-axis, so which is this one. And we'll have the y-axis, which is that one. And the graph. So the graph is this one. So the area should be that red shaded area. So how do you do this question? So we know that when we find the area, it has to be something minus something. So what we want to find is we want to find the equation of the line. So this line, right? So obviously this line right here, that line is y equals to 0. So the y equals 0 is the upper line. We want to minus the function gx, and we want to integrate it from where it cuts. So obviously it cuts at this point. So yeah, sorry, we have that as well. So actually, no, this has to rub out. So yeah, only this red part. So from up to here. Yep. Sorry about that. So let's continue. So we gonna integrate from negative 2 to 0. So we can form our integration negative 2 to 0. We have y equal 0, which is 0 minus gx. Our gx would be 1 over minus 3 x minus 3 squared plus 2. Negative 2. Negative 2 and then dx, right? So we want to transform this into x minus 3 to the power of negative 2, right? So that will be negative 2, 0 there. Negative of x minus 3 to the power of negative 2 plus 2 dx. And that is equal to, so x minus 3, we want to go up by 1 unit. So x minus 3 to the power of negative 1. And obviously we want to put the negative 1 and we want to divide by negative 1. So this is a negative, and when you divide by the negative 1, the negative cancels out. So there's no more negative. So this is now positive. 2 becomes 2x, and all of this 0 and negative 2, right? Then we so we want to sub in 0 and negative 2, and when we something minus something, right? So sub in 0, that would be 1 over, so negative 1 over 3, because 0 minus 3 is negative 3, and then that's the 1 over 3 because it's to the power of negative 1, plus 2x, which is plusing 0. So maybe just plus 0 minus. So we want to sub in negative 2 to this. Oh, wait, sorry, this is x plus 3. Sorry, I was doing it wrong. So plus here, we're fine. So don't worry about this. This has to be 1 over 3. And when we sub in negative 2, it should be negative 2 plus 3 is 1. So that will be 1 over 1. And then for this part, we have negative 4. So negative 2 times 2 is negative 4. So we ended up with 1 over 3 minus 1 plus 4. 4 minus 1 is 3. 3 plus 1 over 3 is 9 over 3 plus 1 over 3. That is 10 over 3. Unit square, actually. Yep. So, yep, that is question 3. Pretty easy, right? All right, moving on to question 4. So this is a binomial random variable. So we all know this is P, which is our probability. That is your N, which is your number of trials. So find the standard deviation. This is quite easy because we already have the formula. So the formula for ST of X, that is square root of N times P times 1 minus P. So if we sub that in, that'll be 4 times 9 over 10 times 1 over 10. And that is square root of 36 over 100. And square root of that will be 6 over 10. Right? So standard deviation is 0.6. Yeah, maybe right. Decimal or fraction. I think fraction should be okay. Yeah. All right. So we have find the PR of x smaller than 2. Probability of x smaller than 2. So we have 4 trials. That means it's either we success 1 time or we succeed 0 time, right? So PR of x smaller than 2 would be equals to PR of x equals to 0 plus x equals to 1. So either succeed 0 time or succeed 1 time. So with the succeed 0 time, it will be 4 choose 0 times by 9 over 10 to the power of 0 times, so obviously that is 1 minus 9 over 10. 4 minus 0 is 4 plus the x equals to 1, that is 4 choose 1 times 9 over 10 to the power of 1 times, so 1 over 10 to the power of 3. Okay, so 4 choose 0 is 1. 9 over 10 is going to be 1. This is going to be 1 over 10 to the power of 4 plus 4 choose 1 is going to be 4. 9 over 10, yep. Then 1 over 10 cubed. All right. So that would be 10 to the power of 4. That would be 10,000. So the other way of thinking of this is to the power of 4. That means you are going to add 4 zeros. So we have 1, 2, 3, 4 zeros. So that's 10,000 plus 36 over 10 times 10 cubed. That is also 10,000. And if you plus that, that will be 37 over 10,000. All right. So question 5. Question 5 is also a reciprocal functions, but this is sort of like a application questions to predict a population of a town after 4 years. So we see here T is the years after, is the population of town after the T years. So obviously if it's 4 years and you sub in T equals to 4, right? So H4 be 3,000 over 4 plus 1. So 4 plus 1 is 5. 3,000 divided by 5 is going to be 600. So 600 people. All right. So let's move on to question 5b. A new function h1 models the population where h10 equals to h0, but h1 decreases at half the rate of h at any point in time. So we can see here half the rate. So whenever we think of the rate, this is going to be diff. Okay. So right away, we need to think about diff ht function. And also h10 equals to h0. That means that if we have, so let's do the diff first because it's about the rate. So we have here, this is 3,000 times t plus 1 to the power of negative 1. If you want to diff that, it will be equals to, so we take the negative 1 to the front. That'll be negative 3,000 t plus 1 to the power of negative 2. All right. So we have h10 equals to h0. So if you want to find quickly here h0, That'll be 3000 divided by 1, which is 3000. So 3000 here. So we already have h dash t equals to this, but the h1, so h dash 1, h1 dash t is half of that, right? So half of this would be negative 1500 t plus 1 to the power of negative 2. So all we want to do next is we want to integrate. So h1t would be integrate of this t, and so t plus 1 to the power of negative 1, and we want to divide by negative 1, so that is timesing by 1500, because the negative is already cancels out. So negative 1500 over negative 1, that'll be 1500. So also we don't forget the constant plus c, and then now this is where we apply this into the questions. So we want to sub in h1 0, that would be 1500 over 1, because 0 plus 1 is 1. And then plus c, that equals to 3000. So equals to 3000. So your c equals to 1500. And so your h1 equals to 1. So negative. Right, so no. So yeah, your h1 is equals to 1500 t plus 1 plus 1500. So the two transformation would be So remember Dr. T. So always dilation should go first, and then reflection, and then translation. So first is we look at 1500, and this is 3000. So that is obviously dilation by factor of 1/2 from the x-axis. All right. And then we have a translation, right? So translation, 1500 units in the y-axis, right? So you can say in the y-axis slash, or you can say from the x-axis, or you can indicate the direction. So 1500 unit up. That'll be easier for the examiner to see that you're conveying the right information. Right. Okay.